Primary School.
My name is Guo Cheng Guang, 8 years old, primary 2, also from YUMIN Primary School.
This lesson is Calculus, Chapter 4, Further Differentiation. For this time, we'll look at this question. For this question, we'll need to know the Fermat's principle. The Fermat's principle, the path taken between 2 points by a ray of light is the optical path that can be traversed in least time. Okay, so for this traversed in least time, that means it can go in the least time, right?
Yes.
But first for this, we'll need to know what is the reflection law, right?
Yes.
So for this reflection law, we have this ray of light. You can also call a ray a beam, right?
Yes.
So for this, what kind of ray do you call this? The incident ray, right?
Yes, the incident is not a kind of incident or accident.
And here is the reflected ray, correct?
Correct.
And here is the normal. And remember, these two angles, they must be equal, okay?
Yes.
Okay, so other than this, for example, here we have a point. And over here we have another point, okay, maybe, right?
Okay.
So for this, we can put the point here, right?
Okay.
And remember, here is a medium. Correct?
Yes.
So for this medium, it can be any medium, right?
Yes.
And medium, the plural is called media. Right?
Yes. Homogeneous.
Okay, we have homogeneous, okay? Homogeneous, okay?
Yes.
So for this means that it goes straight. This is homogeneous, which is also uniformly, right?
Yes.
Other than homogeneous, what else do we have?
Homogeneous. Heterogeneous.
Heterogeneous.
Okay.
The heterogeneous, it can be like this line here first, then another line, correct?
Yes.
Heterogeneous, it can also be here's a line, here's another line, here's the final line. Or it can also be like a curve. Is it correct?
Yes.
Okay, so for this, what else can you think of? What kind? What kind of other heterogeneous? What kind? You can actually draw lines. There are many types. Did you know that? There are many types. Okay, like for example, these 2 points. Okay. Okay, it can be about like this, because there can be many layers, right?
Yes.
Okay, let's draw it more quickly. Okay, it can be quite weird, right?
Yes.
Okay, so actually heterogeneous, there are many types, right?
Also can wait.
Why did it go back?
cannot go back. Cannot go back.
Okay, so for this, can we just stop this over here?
Excuse me. Does that mean cannot go back?
Well, no. Here's a medium, right? Here
Yes.
is medium. If not, it has to go like this, then like this, then like this.
Oh.
Okay, so for this, can we just erase this first? Okay?
Okay.
Okay, so for this, we'll have the next. So when you look at this, what do we need to talk about? And remember here, we also need to talk about. First, can we start here again?
Yes.
The optical path. So for this optical path, this is actually ND, right?
Yes.
It's actually a N times the D. So for this, N. What is N?
N is the refractive,
Refractive, okay?
refractive index.
For this, the N is
C
C over V. What is C? C is the
Speed of light in the vacuum.
Yes, correct, in vacuum. Next,
Speed of light in medium.
okay, so for this, what is the speed of light in the vacuum? Do you know that?
3 times 10 to the power of 8.
What is the unit?
Per meter second.
Meter per second.
Okay.
Okay, so for this is very fast, okay?
Okay.
In 1 second, you can travel around the Earth 7.5 times.
Okay.
And for this, from the sun, the light comes travel to the Earth.
8
Hello?
minutes.
Yes, correct. It is 8 minutes. But 8 minutes, can you think how long is that?
That is
In seconds, it is actually already 8 times 60, 480, right?
yes.
480, you need to times this. 480 times this is a even more bigger and bigger number, right?
Yes.
So can you think how far is it? And how fast this light is? Can you think of that?
Oh, that is very far.
Okay, so for
And
this,
it's also very fast.
okay, so for this, the next is the speed of light in the medium. The medium, it can be any medium, like the air, the water.
The glass.
Okay, so let's talk
Even
about.
yourself.
Okay, so for this, we have this N. We'll talk about 3 cases of the N.
And don't forget D.
Okay, first we talk about N, okay?
Okay.
So,
Later we'll talk about DD.
can you write out these?
Okay.
Okay, this is around 1, right?
Yes, there is
Okay, 1.3 dot. Okay, so actually this is 1.333 infinity threes.
Yes. About 1.3.
Like this, okay?
Okay.
Next, in class. Okay, 1.52, which is roughly 1.5, right? Okay, so for these are
Yes.
three cases. But actually for the air, we say as 1, right? But it's not 1, right?
Yes.
Because that for this 1.000293, it is only very, very close to this, right?
Correct.
And this, it is very close to the speed of light. So what does it mean? If this n, it is bigger, it means that
It's slow.
I say bigger, so bigger, that means slower, right?
It's slow.
Okay.
Slower. It's slower.
What if it is closer to 1?
Faster, faster.
What if it is 1?
Faster.
Okay, so this one, wait, for this unless you're in a vacuum.
Okay.
But until now, there is usually like no such things faster than the light, right?
Yes.
And remember, this is light in vacuum, okay?
Yes.
That light in different things has different speed, right?
Yes.
Okay, so for this, remember, take a look at this, okay?
Okay.
Okay, so can we just erase this?
Okay.
Okay, next, we'll talk about D. Because there's an N and a D, right?
Yes.
So for D, this is the
Distance.
distance.
Okay.
Okay, so later on in this question, we'll actually be talking about this distance. Okay? Okay?
Yes. No P. P for that P.
So for this, the D. It's like nothing has this reflect, right?
Distance.
Okay.
Distance.
Yes, the distance is the D. Okay?
Yes.
Okay, so can we just move on to the question?
Okay. Distance.
Okay, so for this question, okay, just quickly label it.
Okay. There's the x, there's the distance minus x.
Then,
So there's no line and not x.
quickly, that is the,
Distance.
okay, that is the D, right?
Yes.
Okay, so for this, we'll actually need to prove. So our finding is the proof.
Yes.
And for this, we'll need to let, what will we let? Okay, you use X, so I'll use
Y. X.
Y.
Y knows it.
So this is actually a 1 times.
And then AO plus 1 times OV equals AO plus
Y01. Y01. Why do you think it's a 1? Okay, it's a 1 because of the N.
O.
Because it's a ND, right? The
Yes.
distance is this, right?
square, bracket, square.
So for this, is it like this?
Yes.
Then can we find the first derivative? dy over dx.
But D not that.
dy over dx, can we find? So for this, we just look at these, the square root. Obviously that x squared, we have 2x, right? And the 2
Yes.
we need to simplify. So for this, it is actually x over for that. Square root, it is to the power of half, right?
Right.
You put that in front, then when you minus a 1, it is a negative half, correct? Correct?
Correct.
So for the negative half, the 2 cancel, so this is a square root. Like this.
Yes.
Then your minus. Am I right?
Correct.
For this, then this is. Is it correct?
Correct.
Then let the first derivative become 0.
Okay.
Okay, so for this, then times and times, right?
Yes.
Like this, then.
Yes.
Like this, am I right?
Yes.
Okay, so for this, both sides square, okay?
Okay.
So here it is x square bracket, h2 square plus this bracket, d minus x bracket square. Then you need another bracket.
Yes.
And this is bracket d minus x bracket square. Then this is times h1 square plus x square. Then here is the bracket.
Yes.
Okay, so for this, the thing now is to times it in. So first for this, d square, so it's x square d square, right? Then next is a negative 2 xd, right? Correct?
Okay.
You know how? Okay, so just tell me, negative 2xd, so this is a negative?
So there are negative 2dx cubed.
Okay, then the next is for the x squared, right?
Yes.
To the power of?
To the power of.
Then here is here, this is a d squared minus 2x
2x
d
d
minus x
minus
squared,
x squared.
like this.
Yes.
So for this, in front this part still stays the same. But for this, what did you realize?
Something is normal.
Wait, but for this, you see, these. But do you need this? Do you even need this? Do you even need it like this? There's no point having it like this, right?
Oh,
You guys said there's no point having it like this as normal, right?
yes. So,
For this, these cancel, but it's actually no point.
yes.
You don't need this.
So there's another way.
Okay, so for the x, what do you need this? This x over this, right?
Yes.
And then they said that this is because this x, then for this square root is actually this part, and also here is the theta because of is the alternative. What kind of alternative angle? Interior, right? Interior
Yes.
alternative angle, correct? So it's actually
Yes.
theta, correct?
Okay.
So x over the hypo is actually the sine theta, right?
Okay.
But for this, why is it sine? What is that? Sine alpha. Why? Okay, because here is d minus x, then over that is the hypo, which is actually the same thing again, right?
Yes.
Okay, so for this, that is why we get this answer, which is a theta that is alpha. But are we sure that this is, that is following this principle?
Second derivative.
Second derivative, won't it be so long?
Later we will see.
Okay, so for this, we will need to erase all these x because we don't need it, right?
Yes.
Okay, so for this, when we find the second derivative, we use 1 prime prime, right?
Yes.
So for this, the y prime prime, when we look at this part, we can have this 1 over the square root h1 square plus x squared, right?
Right.
And then remember, over here, is it a positive or a negative? Right now it's a negative. Because at the denominator, it is a negative half, right?
Yes.
Then over here, this x squared still comes out, but the half simplified. So this is actually still x, right?
Yes.
Then here is square root. But remember, because that is a negative half, then you minus a 1. So it's a 3 over 2. So this cube, right?
Yes.
Then next is here this minus. So for this minus, actually, there will be another, which becomes a plus, right?
Right.
So for this plus, here we have, is there this square? Wait, but first for this is actually this part, right?
Okay.
Wait, but do we have this square? Yes, right?
No.
Don't we have the square? Don't we have the square? Here is already 1, and here you put another 1.
Oh.
Okay, so for this, then you plus. You have the denominator same, right?
Okay.
But remember, for the next, this first is a negative, then there is another negative, so it's still a negative. Am I right?
Right.
So for this, here we have 2 of this, 2 of this, then here is the square root. And remember, here we have 3 of this right now. So this is not a normal bracket anymore.
Yes.
Remember, there's a square here, then there's a cube here, right?
Correct.
Then for this common denominator, right?
Yes.
That means you times the h1 square plus x square, which is actually a h1 square, because you put these 2 together. Then here's the cube, then your plus. Okay, you put these 2 together. This one you need to times h2 square plus the bracket d minus x bracket square, right?
Correct.
But this is still h2 square over this square root, and then you have the bracket, the h2 square plus bracket d minus x, the square, then the cube, right?
Yes.
But all these are still positive, right?
Yes.
So this is bigger than 0. So it's correct, right?
Yes.
Because that is bigger, that
No.
means it's actually the minimum, right?
Yes. So we don't need to continue.
Okay, so do you get this?
Yes.
So now you get how to prove this. So actually, sometimes you just have to try it out, right? Right? If
Yes.
not, you have to continue with the long things, right?
Yes.
For this, you have to think, be smart, okay? So this part, this is the hypo, right? Because that is the Pythagoras theorem. That is why this is the hypo.
Yes, the Pythagoras theorem.
This is also the hypo because of Pythagoras theorem.
Pythagoras theorem.
So sometimes you just have to think more and the question can be easier. Correct?
Yes, think more and be smart.
Okay, so sin theta, sin alpha, they're the same, right?
Okay.
So this is how you should prove this, okay? So take the look, okay?
Yes, and remember, try to find the shortcut.
Okay, so this Fermat's principle, we can actually use it for anything else, okay?
Yes,
We
and
can put it in physics, the chemistry, okay?
and of course, math.
Well, for this, remember this is actually optics, right?
Yes,
Okay, so can we stop?
and remember to don't use the one that we used just now. First, calculate the x. Need to see what is the question like.
Because they're not asking you to find the x. They're asking you to prove this. Not
Yes,
find x, right?
find x. There's no point. If you find the x, when they tell you to prove this, there's nothing the same.
There's no point using that, right?
Yes, and it's going to sound like endless.
Okay, so can we just stop?
Okay.
Okay, so this is actually very interesting, right?
Yes.
And can we continue next time, okay?
Okay.
Okay, so let's stop.
Bye.